chemical kinetics. Am I audible, Tharif? Tharif, sorry, please do this. Very good. Go for the next. Go for the next. Very good. Mm, Very good, Sarif. Very good, Sarif. Fadil and Shahid, what about you? Any answer from 39 to 42? If you are not able to solve this, just let me know. Very good, Shahid. 41, that is B. Correct. 40. Oh, that is wrong. See, for question number 40, the reaction A B follows the first order kinetic. The time taken for 0.8 mole of A to produce 0.6 mole of B in is 1 hour. What is the time taken for conversion of 0.9 mole of A to this? To produce 0.675 mole of B. So with the help of the first one, we are going to calculate the value of K. So initial concentration is 0.8 mole. And the final concentration, if you are going to see the final, this is your A naught, final concentration will be 0.8 minus 0.6 because 0.6 mole of B produced. So 0.2 is this. Okay. Time is also given 1 hour. So we can calculate K is equal to 2.303 upon T. Time is 1 hour. Log of initial concentration 0.8 and the final concentration 0.2. So with the help of this equation, we can easily calculate the value of K 0. 2.303 into, I can write 2 square, log 2 square, that means 2 log 2, and log 2 has a value 0.3010. And you know that whether you are going to write it 1 or not, it won't affect. And here, if you are going to calculate it, you will be able to get k as this, or you can directly write k as 0. Just wait a minute. In order to calculate it faster, I can write like this. The value of k is 2.303 log of 4. I didn't write like this because I need the value of k. And we need to calculate the time for this 2.303 upon k. K is 2.303 log 4. And here it is log of initial concentration, you can see 0.9. And the final concentration, if you are going to see, if you are going to see the final concentration, that is going to produce 0.675. So you just need to subtract this 0.675. 0.9 minus 0.675, you will be able to get 0.225. And after that, you can calculate the value of t. It will be 1 hour as well. Very simple it is. Is that clear? This and this will be cancelled. If you are going to divide this, you can see the calculation 0.9 divided by 0.225. That comes out to be 4. And log 4 will be cancelled. So the answer is 1 hour. So the answer is B. Is that clear, Sahid? Please do respond. Any answer for question number 39? 39 is also very easy if you're going to look at this. If the rate of the reaction is equal to the rate constant, okay, R is equal to K. The order of reaction, you know that R is equal to K into A raised to the power N, right? So when this R will be equal to K, when the value of this will be equal to 1, and how it is possible? So I can write R is equal to K into A raised to the power 0. Then anything raised to the power 0 is equal to 1. So R becomes K, right? Equal to K. And now you can see the power determines the order of reaction. The power determines the order of reaction. So 0 order reaction it is. So the answer is B, 0 order reaction. Shahid, any answer for question number 42? 42 is also very easy. Should I explain question number 42, Shahid, Fadel? Okay, see question number 42. Half-life of first order is 4 seconds. T half is given for first order. 42 is very good. Fadel, it's A answer. T half is 4 seconds for first order. We need to calculate the initial concentration. No. And the initial concentration is given. We need to calculate the concentration after 16 seconds. So with the help of this, we can easily calculate the value of K. You know that T half for first order reaction is 0.693 upon K. So K will be equal to 0.693 upon T half, that is 4. Now what we need to do is very simple. Apply this formula. K is equal to 2.303 upon T. We need to calculate T. T is basically 16 seconds. Log of initial concentration, that is given 0.12, divided by final concentration, that is given as, let's say, R. You can take anything. And K is already calculated, 0.693 upon 4. And then 2.303 upon 16 log of, we can write 0.12 minus log R. So from here, you can calculate the value of R. Very simple it is. Is that clear? Can I change the slide? Okay. Moving to the next question. Oh, go for this question. Any answer, any one of you? Very good, Tarif. Fadil and Shahid. Very good, Shahid. Fadil, waiting for your answer. So 43, if you are going to see, the plot of concentration of reactant versus time for a reaction is a straight line with a negative slope. Negative slope, that means like this. And this is your for zero order reaction. So zero order reaction is will be like this. Very good, Tharif. You have got the right answer for 44 as well. Shahid, let me know. No, this is a very good question. See, I'm going to explain the question number 44. A substance A decomposes by a first order reaction. The starting initial concentration is this, and A is equal to 2m. And after 200 minutes, A becomes 0.15 m. For this reaction, T half is. So all we need to do is to calculate. Very good, Tariq. All we need to do is with the help of this information, first we need to calculate A. Sorry, K. We need to calculate K. Okay. So we are going to see question number 44. So we can write directly 2.303 upon T log of initial concentration upon final concentration. And we just need to put the value 2.303 time is what 200 minutes, so I'm going to write it here log of initial concentration, that is 2, and final concentration 0.15. Will you be able to solve this? If you're going to solve this, you will be able to get 1.29 into 10 raised to the power minus 2 per minute. And you know that T half is equal to what? 0.693 upon K. So you just need to divide it. 0.693 upon K is 1.29 into 10 raised to the power minus 2. That comes out to be 53.5 or 53.49. So it is your answer A. It is your answer A. Is that clear, everyone? Shayad?
Yes, sir.
Okay. So when we are going to talk about this 44, the answer is A. 45, will you be able to do? Very simple. This is this type of questions I already gave you. What you need to do is very simple. Equation 1 and third in which rate are same, you are going to take that. Establish a relation between this. Like first you are going to do like this. For this, the rate is, oh sorry, for the first one, the rate is what R1 I am going to take. That will be equal to K into 0.012 raised to the power x. We don't know the value of x. And 0.035 raised to the power y. And R3 I'm going to take, you can see K will be constant. And this is 0.024 raised to the power x into 0.035 raised to the power y. Now you know that R1 is given as 0.1 and I'm gonna put the value as well as take the ratio of 1 by 3. 1 by 3. 0.1 and R3 is also 0.1. That will be equal to K into, in numerator you can see I can write 0.012 raised to the power x into, I can write 0.035 raised to the power y divided by, in denominator, K into 0.024 raised to the power x into 0.035 raised to the power y. Only you need to make equation and then calculate this. This and this will be cancelled because power and base are same. This and this will be cancelled. This and this will be cancelled. And here you can see what I can write is very simple. 0.012 upon 0.024 raised to the power x. That will be equal to and that will be equal to 1. So what I'm going to do is very simple. Since this base should be equal to each other in order to equate the power. So what I'm going to do, I can write this. You can see you can write it like 1 by 2, right? So I can write 1 raised to the power 1 is equal to 1 by 2 raised to the power x. So in order to calculate the value of x, this base should be equal. So I can write 1 by 2 raised to the power 0, which is equal to 1. Anything raised to the power 0 is equal to 1 x. So x will be equal to 0. That means here the value of x, that means a rate is equal to K into A raised to the power 0 we got. We need to calculate the value of B. Are you getting my point? We need to calculate B now. Is that clear? So for that, what you are going to do, take this one. Just wait a minute. Which one we should take? We should take in which A is equal. This one. If you are going to take this one, you will be able to uh, cancel xx, and you will be able to get 2 raised to the power y, and here you will be able to get, here it will be 2 raised to the power y, and that will be equal to 2 raised to the power 3. So this and this is equal to equal, so y is equal to 3. So the answer will be rate is equal to k into b raised to the power 3. A cannot be equal to power 1, and since a is equal to 0, so you can manipulate that. So answer is it. Please do write it. Everyone done with this? I'm gonna change the slide. Please do this. Oh, 46D is wrong answer. See, when you are going to increase the number of molecules, increase in concentration of reactant, then the number of collision per unit uh, per unit volume per second will be increasing, so leads to change in collision frequency. Is that clear, Shahid? Any answer for question number 47? Very good, Tarif. No, it's wrong, Tarif. 47C. For a reaction, activation energy EA is equal to 0. Okay, activation energy equals to 0. And the rate constant at 200 Kelvin, that means K 200 Kelvin is equal to basically 1.6 into 10 raised to the power 6 per second. The rate constant, we need to calculate rate constant at 400 Kelvin. At 400 Kelvin will be, given that R is given as 8.314 joule per Kelvin per mole, right? So what we are going to do, use that formula, modified form of Arrhenius equation, log K 400 upon K 200, that will be equal to EA upon, here it will be 2.303, and here it is T2 minus T1 upon T1 T2. Very simple. Now, as you can see, this is 0, so the whole quantity becomes 0. Log K 400, that will be upon K 200 will be equal to 0. So log 0, that means log 1. Log 1 can be equal to this, and log cancel. So K 400 will be equal to K 400 upon K 200 will be equal to 1, and K 400 will be equal to K 200. That means the value of this constant, rate constant, at 200 equals to rate constant at 400. So the value will be 1.6 into 10 raised to the power 6 per second, because this has the same value. So the answer comes out to be C. Okay. So 47, it is C. Very good. Or if 49, you have given correct answer. Any answer for 48? The addition of catalyst during a chemical reaction alters which of the following quantities? Entropy, internal energy, enthalpy. It doesn't do these things. It only interact with activation energy. Basically, when you are going to add any catalyst, so generally what happens here, catalyst decreases the activation energy, so the reaction increases. The reaction will be going faster. Okay. And 49 is very simple. The activation energy of a reaction can be determined from the slope of which of the following graph? That is your, oh, wait a minute. ln K versus 1 by T. This is the graph that you plotted with the help of this formula. Can I change the slide? Shahid. Please do. Oh, this is the same. Please do this. Yeah, that's what I was asking. Please let me know when you are done with this. Are you done with this?
Yes, sir.
Please do this. Question number 50 is very easy. I'm gonna give you a hint. You can use this formula. Log K2 by K1. That will be equal to EA upon 2.303 R and 1 upon T1 minus T2. So you can see here activation energy of its rate doubles. If you are going to take K, this will be 2K. So it will be something like that. Initial K, initial you are going to take K. This is your K2. So what you need to do, finally it becomes 2K. So initial is K. And EA upon 2.303 R is also given 8.314. And here 1 upon T1. T1 is 293 and T2 is 1 upon 308. And you can solve it easily, right? So you can use the value of EA easily. Yes or no, K and K will be cancelled. Is that clear? 51 is B, that is correct answer. A reaction having equal energies of activation, that will be 0. Delta H will be equal to activation energy forward minus activation energy backward, and it becomes 0. Equal they become, so 0 delta H will be equal to 0. 52, B and D both are correct. B and D both are correct. Is that clear, both of you? All of you? Yes or no?